Farnborough Air Show 2018. We've popped in to see Starrag and our friend Paul. How are you doing?
I'm very well, thank you, Colin. First of all, welcome to the Starrag booth here at Farnborough.
Thank you very much. How's it going?
It's going very well. The Monday was good. We've managed to meet new customers as well as existing customers, and we were very lucky to agree an order on the first day, which is always a good start to a show.
Excellent. So that's why you're looking a bit bleary-eyed this morning.
Absolutely.
Clearly, only joking on that one. But Starrag machines, I'm thinking big aerospace parts. Is that right?
Yeah, you're absolutely right, Colin. But we're also working with small and medium-sized parts, the detail parts of aircraft, components both in aluminium and titanium. We also machine large landing gear beams. We machine turbine blades for the engines, casings, the avionics, very, very small micromechanical parts for the avionics.
Right, okay, so I was slightly incorrect. So it's tiny precision to big wing spars.
Absolutely, yes. Okay. So these wing spars or even the wing skins can be up to 20 or 21 metres in length.
Right. Now, as an engineer, I'm thinking your machines are, your whole package is a solution, not rather than a normal subcontract engineer, is that right?
Yeah, absolutely, yes. Normally when people are coming to us, they like us to offer a full technology package. So it's not just the machine, it's not just the fixturing, it's the programming, the actual process, and we have to deliver the process to the customer. Right. From the customer's point of view, they're buying their machine tool, it arrives on their shop floor, it's good to go straight away.
Okay, excellent. Now, having watched some of the videos you've got here showing, did I see NQL going on there?
Yes, you did see MQL, but it was also with cryogenic, where we're machining the harder metals with the use of cryogenic coolant, and with MQL as well, where we're pulsing the MQL with the cryogenics, mainly to get fantastic tool life.
Oh, so improving tool life, improving cycle times as well?
It can improve the cycle times. It's not a fixed process. You have to develop the process, but invariably you improve the cycle time as well, and reduce your tooling costs significantly.
Okay, again, I presume application specific though?
Yeah, it is application specific.
Okay. So what else are you showcasing on the stand?
So today we're talking about the whole range that we can machine. We're showing some of our very small parts from the avionics industry, fuel injectors for the jet engines, etc., which need to be extremely accurate to ensure the fuel supply is consistent into the engine. We're also displaying very high accuracy machines, for example, for the manufacture of helicopter gearboxes, where the holes in the gearboxes need to be very accurately done, and we're doing that on super precision horizontal production machining centres. Okay.
Also, I want to talk about, well, you mentioned some of the materials, titaniums, aluminiums. Composites is big in the industry, or moving forward. Where do you stand with that?
Yeah, we've been working with composites for quite a while, but it's not just your standard composite machining. Normally we're working in areas where high accuracy is required. So you're working with very, very large machines where the volumetric accuracy is very important to position the machine with regard to hole drilling through the composite stack.
So again, a lot of aerospace, and that's where you differentiate your machines. How do you actually differentiate the machines? You know, are they differently manufactured? What's in them, without giving away too many trade secrets?
So say, for example, for the large capacity aluminium machines for aerostructure parts, those machines are really specific for aluminium. They've been designed to accelerate at very high rates. They've been designed to move very quickly, and it's all about removing the aluminium. So they would not be suitable for titanium machining, for example. They wouldn't be suitable for standard steel machining. They are designed specifically for very effective aluminium machining.
So where to next?
Well, as ever in this world, Colin, everything's moving very quickly now, and all of our customers are really looking for more effective machining of their components. Their customers are putting the pressure on them to drive down the prices. They're looking to us to come up with new machining processes so they can deliver that to their customers.
Okay. Well, we look forward to seeing that very soon. In the meantime, I hope you have a fantastic Farnborough 2018.
Thank you very much, Colin. Thank you.